Hey everyone, welcome back to the Hacker Stacker channel. Let's say you bought some silver and you're rather suspicious about it being genuine. Yeah, it might be silver, but is it pure silver? Maybe the weight is a little off, or the dimensions are just outside of specs, or maybe it didn't quite ping correctly. Close, but not close enough. Here is how to find out if your silver is truly 3 or 4/9 silver. You measure its relative density. Relative density is also known as specific gravity. It's the ratio of an element's density compared to the density of another element. In the case of solids like silver, it's usually compared to water. Pure silver, whether it's 3/9 or 4/9, has a relative density of 10.49. Now that's not 10.49 troy ounces or any other unit of measure. It's just 10.49. This means equal volumes of water and silver, the silver will be 10.49 times denser than an equal volume of water. Now we can use this information to verify a suspect item's actual composition. To do so, you'll need a little bit more equipment and substantially more time than any of the other tests I've offered up here on my channel. So let's get started with what you will need. First, you will need a short piece of sewing thread. If you like, dental floss can be used as well. But whatever material you use, it must be very, very light. Using something like paracord or mason's line or even a piece of metal wire will skew the results. To prepare the thread, I simply doubled over one end of it and tied an overhand knot. This created a small loop. I then took the other end of the thread, ran it through that small loop, and gave me a large adjustable loop, kind of like a lasso. The next thing you will need is a container of water. The container needs to be large enough to not only suspend your suspect bullion or coin in the water without touching the edge or the bottom, and it must be fully submerged in the water. You will also need some scratch paper and a pencil or paper because you will be writing down some numbers. And if you're like me and you can't divide multi-digit numbers in your head, you'll need a calculator, and I will simply use this one that's here on my phone. Since we're working with an open container of water, it's also a good idea to have some rags or some towels handy to pick up any spills that we might encounter. And the last thing you're going to need is a scale. And not just any scale will do. The scale must have two specifications for this test to work accurately. First, it must be able to accurately weigh more than the weight of the container and the water. Now this container is plastic, and with the water, it weighs a little less than 8 troy ounces. Now this scale is rated up to 500 grams or 16 troy ounces. So that aspect is covered. Your scale must also have the ability to have 3 digits to the right of the decimal point. If your scale only has 1 digit to the right of the decimal point, it's totally useless. And even 2 digits, there's enough variance on how that scale rounds off that it may not give you accurate results. So many of these small pocket scales that a lot of stackers have either don't have the accuracy of 3 digits, or they simply cannot weigh something this heavy. These things top out at 50 or 100 grams. So this is not going to be able to be weighed on this, even if it did had 3-digit accuracy. Now it doesn't matter what unit of weight your scale is set at, grams, ounces, diamond weight, troy ounces, whatever. As long as your 2 measurements are taken with the same unit and at 3-digit accuracy. That's all you need. For this demonstration, I will be using troy ounces. Now before going further, I'd like to take a moment to thank you for taking the time to watch my videos. Be sure to like, share, comment, and subscribe, and hit that bell to get notifications on new content, because it's your support that's going to make this channel grow. Now that we have everything set up, it's time to start our test. I want to reiterate This is a rather time-consuming test compared to all the other, but it's one that can either exonerate a suspicious bar, coin, or round, or determine that it's either a lower grade silver or even some other metal simply with a thin plating of silver. So the first step is going to be, we're going to weigh the silver. I'm going to set the silver on the scale, and I'm going to write that weight down. 1.00335. Then I will prepare the silver to be suspended in the water, and this is what the small thread is for. I'm going to lasso it with the thread, and I'm going to bisect the coin so with the loose end I can suspend it in the air like that. I'm going to carefully set that down, and now I can place my container with the water on the scale. Now, I'm not interested in knowing how much the water and the container weigh, so I will press the tare button to zero out the scale. What I'm interested is knowing is how much this coin weighs suspended in the water. Yes, suspending the coin in the water, some of the weight of the coin will be impressed on the water. So, carefully picking up my suspect eagle. It slipped out there, so I had to redo it, and I edited that out. Make sure I'm bisected again. Sometimes it takes a little bit of work to get it right in the center so it will balance. Now I'm going to drop the eagle into the container and suspend it in the water, making sure that it is not touching the sides or the bottom, and it is completely suspended in the water. And I get a number of 0.09, keeps bouncing around on me because of movement. I want to say 550. I am now done with taking my measurements. As I stated, pure silver has a relative density of 10.49. When I divide these two numbers, I should come up with a number close to 10.49. Now, actually, anything from 10.4 to 10.6 is going to be accurate. Okay, I had a little incident there where my camera overheated and shut down. So, if that explains the little change that you had in the scenery there. I'm going to divide the first weight that I got of the plain dry weight of the eagle by the weight of the eagle suspended in the water. I should get a number close to 10.49. Not exactly 10.49, but somewhere in the range of 10.4 to 10.6. So I'm going to take my numbers, and 1.00335 divided by 0.0955 equals 10.506. And that is well within specs to consider this coin pure silver. Now, you can use this test for other metals that you may stack, like gold, platinum, and other metals. The only thing that will change is that relative density for those metals. And those numbers are easily found with a simple Google search for those interested in testing other metals you may be stacking. But for now, we've determined that this eagle is indeed genuine 3/9 silver at minimum. So keep on stacking, and I'll see you in the next video.